If an advanced industrial civilization existed millions of years before humans, could we find proof of their existence? The famous and controversial Drake equation is commonly used to estimate the number of communicative civilizations in the universe. One of the factors considered in this equation is L, or the longevity of a civilization. How much time does a civilization have to communicate its presence to the rest of the universe? Given that complex life has existed on Earth for around 540 million years, and humans as a species have only been around for roughly 300,000 years, it is scientifically interesting to ask whether another advanced industrial civilization could have preceded us, even though, to be clear, there is currently no evidence that one did. Hello, Dr. Alejo here. One of my favorite science communicators is astrophysicist Dr. Adam Frank. His views on extraterrestrial life are inspiring and thought-provoking. In 2018, Dr. Frank collaborated with Dr. Gavin A. Schmidt, a climate scientist at NASA, and proposed what they call the Silurian hypothesis. The 2018 paper, the Silurian hypothesis, would it be possible to detect an industrial civilization in the geological record, addresses a simple but profound question. Could we detect evidence of a pre-human advanced industrial civilization in Earth's geological record? Importantly, they were not arguing that such a civilization existed. They were asking whether, if one had existed, we would even be able to detect it. The quest of detecting extraterrestrial civilizations can pretty much be summed up into two questions. First, do alien civilizations exist? And you may think, obviously. Given how vast the universe is, they have to exist. But wait a minute, the apparent obvious answer is not really that obvious. The conditions for life to emerge on Earth seem to be quite specific and not fully understood. We have discussed this in other videos: our large moon, plate tectonics, our positions in the Milky Way, and our location in the solar system, and so on. So contrary to popular belief, the existence of other civilizations is not a trivial question. Second, if such civilizations do exist, are we able to detect them? This doesn't just depend on technology. It depends on location and timing. We must be positioned in such a way that we can receive a signal. Imagine if a civilization is transmitting, but our receivers are not pointed in the right direction. And timing, what if a civilization transmitted for 1,000 years, when the dinosaurs ruled the Earth? One reason dinosaurs went extinct was an asteroid impact, which they didn't see coming. So we can pretty much rule out the existence of a dinosaur space program. Therefore, I seriously doubt they had radio telescopes listening for signals from outer space. So, for a civilization to be detected, it needs to transmit long enough so that another civilization can receive the signal. This transmission time is what the Drake equation tries to capture in the parameter L. The Drake equation, formulated by Frank Drake in 1961 as an agenda for a SETI meeting, is a probabilistic framework used to estimate the number of active communicative extraterrestrial civilizations in the Milky Way galaxy. It considers the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, the fraction of planets where life appears, the fraction of planets where intelligent life develops, the fraction of planets with life that invents detectable technology, and finally, parameter L, the length of time that civilizations transmit detectable signals into the universe. We explored this in greater detail on our fully dedicated video of the Drake equation, which I invite you to check out. The Drake equation, however, sort of implies that only a single civilization could arise during the life of a planet. It estimates how many civilizations exist at a given time, but it doesn't model repeated cycles of rise and collapse. Could that have happened on Earth? Life on Earth has not followed a straight line. During the 4.5 billion years of our planet's history, life has experienced multiple mass extinction events. In his book, The Ends of the World, Peter Brannan discusses 6 major extinction events that have reshaped life on Earth. However, life itself has never completely disappeared. The biosphere we see today traces its ancestry back to a common ancestor known as Luca, the last universal common ancestor, which lived billions of years ago, long before the most recent extinction events. Complex animal life emerged during the Cambrian explosion around 540 million years ago. As for human-level intelligence, Neanderthals lived roughly between 400,000 and 40,000 years ago. Denisovans likely existed between about 300,000 and 50,000 years ago. Modern humans, Homo sapiens, have existed for around 300,000 years, and our common ancestor with Neanderthals and Denisovans lived around 600,000 to 800,000 years ago. And yet, our current advanced industrial era has only lasted for about 300 years. Many scientists argue that we are now entering a proposed geological epoch known as Anthropocene. Anthropo, human, scene, recent. A proposed epoch in which human activity has become a dominant force shaping Earth's climate, chemistry, ecosystems, and geology. If complex animal life has existed for over 500 million years, this could be enough time for another human-like advanced industrial civilization to have flourished. However, there is currently no geological evidence for such a civilization. But could it be? Enter the Silurian hypothesis. The Silurians are a race of intelligent reptiles awakened by an experimental nuclear reactor. Of course, they are not real. This is just sci-fi. The Silurians were introduced in a 1970 episode of the science fiction TV series Doctor Who. The Silurian is a geological period spanning approximately 444 to 490 million years ago. Contrary to some wild conspiracy theories, the authors Frank and Schmidt were not suggesting there are lizard people walking amongst us, or that we're intelligent reptiles during the Silurian age of our planet. Before going any further, it is important to clarify something. We're not talking about Atlantis here. The Atlantis story originates in the writings of Plato around 360 BCE. It describes a powerful civilization that supposedly existed thousands of years before his time and was destroyed in a cataclysm. But Atlantis, whether myth, allegory, or misunderstood history, is a story set only a few thousand years in the past. The Silurian hypothesis operates on a completely different scale. Millions of years, not thousands. If an advanced civilization had existed only 10,000 or 20,000 years ago, we would almost certainly have found clear archaeological evidence of it by now. The question Frank and Schmidt are asking is far deeper and more unsettling. If there was indeed an advanced civilization millions of years ago, would we even know? The geological record could not be sufficient to detect an ancient industrial civilization. Evidence in the last 2.5 million years shows support for the existence of climate changes and even archaeological evidence of non-Homo sapiens cultures. However, if we go before 2.5 million years, evidence and fossils become harder to find. For instance, the recycling of ocean crust through plate tectonics has only allowed sediment evidence after the Jurassic, around 170 million years ago. Most life doesn't leave behind fossils we can analyze. Despite dinosaurs ruling the Earth for nearly 200 million years, there are only a few thousand near-complete specimens worldwide. If a civilization lasted 100,000 years and existed tens of millions of years ago, the probability of finding direct artifacts or fossils might be extremely low. Evidence of any objects or structures used and built by such a civilization could also be hard to find. I remember watching the Life After People documentary from the History Channel a while ago, where they showed how long our buildings would survive if humans were gone. It wasn't really a good picture to see. The trailer would include the cryptic line, "After 1,000 years, there would be very little evidence of the activities of men." Creepy. Schmidt and Frank argue that for a civilization that existed more than 4 million years ago, it would be really hard to find direct evidence, either via the objects or fossilized specimens of their population. But if physical evidence, fossils, or objects can't help us find one of these previous civilizations, what could? In astrobiology, the term technosignature is used to describe the evidence of some technology that modifies its environment in ways that are detectable. Although this concept is usually applied to the search for extraterrestrial intelligence, we can use it here to search for evidence for a possible pre-human civilization. To do so, we can use our own civilization as a template. On a topic that shouldn't be that controversial, but unfortunately it is, since the mid-18th century, humans have been pumping fossil carbon to the atmosphere. An estimated quantity of around 0.5 trillion tons of carbon has been released. This is the result of the burning of coal, oil, and natural gas. This release has occurred faster than natural long-term sources. As a matter of fact, way faster, as in orders of magnitude faster. We humans are also responsible for large deforestation around the globe and pumping of carbon dioxide into the air as a result of biomass burning. A key characteristic of all of these carbon is their biological origin. Biological carbon is released to the atmosphere when we burn fossil fuels and biomass. This biological carbon has a lower ratio of carbon-13 to carbon-12. On the other hand, inorganic carbon sources such as carbonate rocks, volcanic activity, and oceanic dissolved carbon have a higher ratio of carbon-13 to carbon-12. So, evidence that the ratio of carbon-13 to carbon-12 is decreasing in the atmosphere is quite large. This is known as the Suess effect and is one of the strongest geochemical fingerprints of human activity in the atmosphere. The increase of fossil carbon in our atmosphere, as well as greenhouse gases such as nitrous oxide, methane, and chlorofluorocarbons, has caused a warming of about 1 degree Celsius since the 19th century. The evidence is just there, so yeah, global warming is really a fact. Such a rapid increase in temperature in a matter of hundreds of years cannot be explained by known volcanic or orbital cycles and is strongly consistent with human-generated greenhouse gas emissions. Our agricultural practices have significantly modified Earth's nitrogen cycle. The widespread use of nitrogenous fertilizers and enhanced nitrogen fixation have contributed to this. We can see proof of this change in the nitrogen cycling as very distinctive isotopic signatures, which get preserved in sediments, providing a possible way of detecting a civilization that, like us, was using synthetic fertilizers, for instance. Our agricultural practices, which usually require extensive deforestation, have caused a significant increase in soil erosion. This, combined with the canalization of rivers, is resulting in much greater oceanic deposition of sediment at rates far exceeding natural background levels. Global warming, which once again is very real and driven by human industrial activity, is also resulting in rising sea levels and reduced sea ice in polar regions. Deforestation and agriculture increase sediment and nutrient delivery to the oceans, altering marine chemistry and potentially amplifying acidification driven primarily by excess atmospheric carbon dioxide. The increase in atmospheric carbon dioxide dissolves into the ocean, forming carbonic acid and lowering ocean pH. This reduces carbonate availability and can increase the dissolution of calcium carbonate shells in marine sediments. A rapid carbon isotope excursion combined with changes in carbonate deposition could leave a long-lasting geological signal. It is worth noting that the Earth has indeed experienced rapid increase of temperature, ocean acidification, and perturbations to the carbon cycle. Around 56 million years ago, in a period known as Paleocene-Eocene thermal maximum, or PETM, global temperature rose by roughly 5 to 8 degrees Celsius. However, such changes unfolded over several thousand to tens of thousands of years. We humans are also responsible for large extinctions of a number of species on the planet, and we are also responsible for the redistribution of certain species. Rats, mice, cats, for instance, have spread to geographical zones that they shouldn't normally be present. Both presence of species in non-natural habitats, and extinctions will have either a presence or disappearance from the fossil record, which will be noticed by future anthropologists. There are also many materials and chemicals that are the result of our industrial processes and our way of life, and that we have disseminated all around the world. Persistent organic pollutants, POPs, which are organic molecules that don't degrade by chemical, photochemical, or biological processes, are an example of this. Most modern plastics are fully synthetic, petrochemical polymers that do not occur naturally in significant quantities. Since the 1950s, we have been delivering large amounts of quantities to the oceans. Many common forms of these materials could degrade, impeding their future detection. By macro or nanoparticles of plastic could be potentially detected in marine sediments. Finally, our nuclear technology can also be a sign of our existence, specifically plutonium-244, which has a half-life of nearly 81 million years, and curium-247, with a half-life of 15 million years. In principle, if large quantities of these isotopes were produced and dispersed, for example through a sufficiently intense and long-lived nuclear war, they could remain detectable for millions of years. Since there are no significant natural terrestrial sources of plutonium-244, and an anomalous concentration in sediments could represent a geological smoking gun for past technological activity. The Silurian hypothesis is not a claim that such a civilization existed. It is an intriguing and humbling question. Will we even really know? While it may be extremely difficult to detect such a civilization on Earth, the same geochemical principles can guide our search for extraterrestrial intelligent life on other planets. We could excavate on Mars or Venus, or even other moons of our solar system. Sediments might preserve isotopic or chemical signatures that could signal the existence of such civilizations. In exoplanets, which are planets outside of our solar system, the presence of greenhouse gases or nuclear isotopes in their atmospheres could indicate present or past advanced industrial civilization. If you enjoyed this video, don't forget to like, subscribe, and press the bell icon so you don't miss future uploads. Also, don't forget to check my book, A Story of More Than 5,000 Worlds, where we explore many SETI-related topics. We explored some ideas about why we don't hear from anyone out there in our Fermi Paradox video. In there, we explored the concept of the gray filter. For example, reaching nuclear maturity could be one of those filters that life on a planet needs to overcome. What do you think? Are humans the first advanced industrial civilization on Earth? Let me know in the comments. That's it for now, and remember, the truth is out there.